Am I audible? Voice is clear?
Yes, sir.
My voice is clear?
Yes, sir.
Okay.
Good morning, sir.
Good morning. So let's start today's class. Okay. So till now we have completed all our crystal structures. So today I'm going to basically give you a summary which we have studied in last 6 structure. Okay, and this chart is quite important for you. I already told you guys. Okay, so I'm making here again all complete 6. Someone mic is on. किसी का mic on है क्या? Okay, no, it's good. So I'm making a chart here. Okay, and this chart will be quite important. So draw with me. First, write down the crystal structure. Okay. Okay, let's do one thing. You can write as just simply name crystal. Okay. यहाँ से आप जान जाओगे कि किसकी बात हो रही है. Then the next point will be an effective. Okay. So, and the next is R versus A. Other is atomic packing fraction. Other is coordination number. Okay. And I am denoting as NN stand for nearest neighbor. SNN stand for second nearest neighbor. Okay. And third nearest neighbor. I guess it is visible for you guys. Okay. TNN means third nearest neighbor. Okay. So we are going to make a chart. First of all, what was the first lattice? It was simple cubic. Okay. What was the ineffective for simple cubic?
1.
2.
Oh, 2 कहाँ से हो?
1.
One, sir.
Okay. And ineffective was 1. R versus A. क्या था?
A equal to 2 R.
Yes, R is equals to A by 2. Atomic packing fraction.
50.
Fraction.
52.
52%. Coordination number?
6.
6. Nearest neighbor distance. At a distance A. So I will write as, see, I will write as 6 at A. Okay, आप ये समझ जाओगे. इससे क्या होगा ना? The nearest neighbor distance and number of nearest neighbor both will be covered. 6 at A. Okay. Second nearest. Second nearest neighbor.
A root 2.
12 at A root 2. Okay. At A root 2. Third. Third nearest neighbor. And number of third nearest neighbor?
8.
8. 8 at root 3A. It is visible now? Third nearest neighbor is visible?
नहीं सर अंदर
Sir,
जाना
A root 2, it is the nearest neighbor distance.
6 at A.
Hello, sir.
6 at A. 6 at A means there is 6 nearest neighbor at a distance A. Second
Okay,
nearest neighbor means 12 second. There is a 12 second nearest neighbor at a distance root 2A. Similarly, there is a 8 third
Okay,
nearest neighbor
neighboring
at a
distance.
root 3A. See, this is the distance. This is the
Okay.
number. Simple. ये तो आपको दिख रहा है ना? ये तो distance है, ये number है. Okay?
Okay, sir.
फोकस नहीं हो रहा है सर अच्छे से.
क्या हुआ?
तो फोकस थोड़ा सा
नहीं फोकस ठीक है. एक्चुअली वो एंड ऑफ द बोर्ड है ना. दिस इज एक्चुअली एंड ऑफ द बोर्ड. सो इसीलिए थोड़ा सा ना वो पोर्शन कट जा रहा है. नो वरी, आप तो इसको जान जाओगे ना. थर्ड नियरेस्ट नेबर तो आप खुद भी लिख सकते हो. दैट इज रूट 3 है. ओके, नंबर आप खुद लिख लेना. दैट विल बी 8. आई विल कन्वे दिस. रूट 3 है. देयर इज अ 8 नियरेस्ट थर्ड नियरेस्ट नेबर एट अ डिस्टेंस रूट 3 है. सेकंड वन, व्हाट वाज द BCC? Okay, n effective
2.
2. R versus A
R equal to root 3a by 4.
root 3a by 2 or 4.
4 sir.
4
4
4
था
sir.
ना, nearest neighbor distance root 3 by 2 था ना, तो R तो 4 हो जाएगा. Atomic packing fraction
0.68.
68%. Coordination number, what was the coordination number? 8.
8.
8. Nearest neighbor 8
Root 3a by 2.
at root 3a by 2. Second nearest neighbor
6 at a.
6 at A. And for the third,
12 at a root 2.
yes, at the distance a root 2 and it will be 12. Okay, 12 at a root 2. इसको actually आप ना ठीक से लिख लेना, जैसे ये लिख रहे हो बिल्कुल वैसे इसको भी लिख लेना, 12 at root 2a. Okay, now what was the third type of lattice? FCC. N effective
4.
R versus A, क्या था relation?
A by 2 root 2 is equal to A. R.
Yes, A by 2 root 2. Now atomic packing fraction
74.
74.
74%. Coordination number
12.
at a distance,
A by root 2.
A by root 2.
yes, A by root 2. Second nearest neighbor,
A.
A.
number of
6 at A.
6 at
Six.
A. ठीक है ना? And what was the third?
24 at root
Yes,
2a.
yes,
3 by 2.
yes. Complete root of 3 by 2a, and number of third nearest neighbor was 24.
24.
Okay. What was the fourth one? First, let's talk about the diamond. Let's talk about the diamond first. Diamond. N effective for the diamond. N effective for the diamond. अरे कल ही तो किया है.
8.
2.
8 sir.
2.
2
Eight,
नहीं
sir.
8
2
8 सर
8 होगा ना. FCC है तो 2 तो वैसे नहीं होगा. Okay.
हाँ सर.
Yes.
सर एमसीसी में आपने TNN का लास्ट में क्या लिखा है? √3/2a इंटू.
Root 3 by 2 into A.
24
Lattice
ओके
parameter.
सर उसका
And
वो
number of third nearest neighbor will be 24.
24
ओके सर. यस सर.
Okay, so for the diamond cubic, N effective is, what is R versus A?
R equals
Sir,
to
R equal to
root
root
3 by 8.
Yes, root 3 by 8A. Now, atomic packing fraction
34.
34.
34.
34. Good. Coordination number
4.
4.
4. At a distance
Root 3a by 4.
root 3A by 4. Good. Now, second nearest
12.
12 at
A by
A
root
A
2.
by root 2.
हाँ, third find out किया था? Anyone? Find out किया था किसी ने? कल homework दिया था ना मैंने ये. I gave you homework. Finding out the third nearest neighbor of for the diamond.
सर एक दिन और दे दीजिए.
एक दिन और देते हैं.
यस सर.
Okay, चलो. Today is also the same homework. Okay, कल बता देना क्या है. चलो
यहाँ
इसको
से फाइंड आउट करेंगे
हाँ exactly इसको अभी ऐसे वैकेट छोड़ दो. देखते हैं क्या है. ठीक है. Now what was fifth one? Hexagonal close pack. Hexagonal close pack, that is SCP. N effective for the SCP
6.
6. R versus A
R equal to A by 2.
A by 2. Packing fraction
74.
74.
74. Coordination number
12.
12.
12.
Nearest neighbor
A.
12 at A. Second nearest neighbor
6 at A root 2.
6 at A by root 2. A by root 2, right? No, it's root 2A.
Sir, A root 2.
Yes, A root 2. Third nearest neighbor 2
What?
at C. See, I am writing this by the 12 comma A. Okay, आप समझ लोगे what is written there. Means there is a 12 nearest neighbor at a distance A. There is 6 second nearest neighbor at a distance root 2A. And there is a 2 third nearest neighbor at a distance C. C means what? Under root 8 by 3A. Okay? इसको कंप्लीट करो, फिर इसको रब करके NaCl की बात करते हैं. कंप्लीटेड हो गया सबका?
यस सर
ओके यहाँ पर बात करते हैं NaCl की. Okay, so our sixth one is sodium chloride. Sodium chloride, yes.
सर सिंपल क्यूबिक में सर सेकंड नियरेस्ट नेबरहुड में सर आपने क्या लिखा है, क्लियर नहीं हो रहा है.
This is written as 12 at a root 2.
ओके सर.
Okay, 12 at a root 2. Chalo, let's talk about sodium chloride. What is the N effective?
ए बाय रूट तो आएगा सर वो सिंपल क्यूबिक का.
A by root 2 आएगा.
सॉरी
root 2a होगा ना.
हाँ
The front atom will be at a distance a, that will be nearest neighbor. The face diagonal atom will be at root 2a. So second nearest neighbor will be root 2 है ना. A by root 2 पे तो atom ही नहीं है simple cubic में.
मुझे अच्छे से
सिंपल क्यूबिक में तो A by root 2 पे atom ही नहीं है. NaCl, N effective
8
8. R versus A.
R N plus R C क्यूब बाय.
Yes, R is equals to 2 of R of Cl plus R of Na. इसको ऐसे ही लिखना होगा, ठीक है ना, इसलिए मैंने इसको लास्ट में कराया. पैकिंग फ्रैक्शन
A is equals to sir.
सॉरी yes no okay yeah sorry A is equals to twice of right. Now packing fraction.
expression होगा.
Yes, exactly. Write down that expression, and the expression was 2 pi by 3 okay R of Cl cube plus R of Na cube. Is it visible now? Yes. And whole divided by R of Cl plus R of Na whole cube. Okay. Now, what was the coordination number of sodium chloride? 6. Okay. Nearest neighbor?
A by 2.
A by 2.
And number of 6 at A by 2. अच्छा, मैं आपको एक चीज बता रहा हूँ. I'm telling you one thing. For the sodium chloride, just write it that is 6 at A by 2, and below this just write down different. ठीक है ना? What is different stand for? It means whether any exactly the ions you are taking on the as a reference, then the first nearest neighbor will be opposite to that, different for that. If you are taking Cl, then the nearest neighbor will be sodium, and if you are taking sodium, then the nearest neighbor will be chlorine. Okay. Second, what was the second nearest?
12
At
A by root 2.
12 at A by root 2. Write down as same. Same means if you are taking chlorine, then it will be chlorine, and if you are taking sodium, then it will be sodium. What was the third nearest?
8 at root 3.
8 at root 3.
Yes, exactly. It will be 8 at root 3 by 2a. Okay, लिख लोगे ना? चलो, ये थोड़ा सा कट रहा है यहाँ पे. मैं इसको यहाँ पर लिख देता हूँ. I am writing down here. 8 at a distance root 3 by 2 is the complete root here, हाँ? और उसके बगल में लिख लेना what? Different. ये भी different होगा. Okay? You guys will be understand ना? What is different and same and different stand for? ठीक है ना? इससे क्या होगा कि जब रिवीजन करोगे आपको तुरंत पिक्चर क्लियर हो जाएगा. ओके
सर
यस.
अराउंड डायमंड का एपीएफ कितना आता है, मतलब परसेंटेज में, ये अगर वैल्यू
डायमंड,
हाँ सॉरी डायमंड नहीं, सॉरी NaCl का RCl.
देखो NaCl, the thing is when you are taking the ionic radii, okay, if you are whether it is taking ionic radii or atomic radii, if you are taking the ionic radii of Cl and sodium, and when you put the data here and you find out, you will get is around 66%. Is 0.66. Okay, it is a 66%. And when you take the atomic radii of sodium and chloride here, so when you see the data, and if you see on the internet, the data suggests that the radius of chlorine and radius of sodium is almost equal, almost, not exactly, almost equal. So when you solve this, then the atomic packing fraction comes out around 52 or 53%. Okay.
Okay, sir.
Okay. So this is our complete discussion regarding the lattices.
एक्सक्यूज मी सर ये जो आपने हेक्सागोनल क्लोज पैकिंग का थर्ड नियरेस्ट नेबर लिखवाया है, ये क्या लिखवाया
Two
है?
at C. There is a third nearest neighbor at a distance C. C means
C
what?
is equal to root 8 by 3.
Under root 8 by 3 है.
जी सर.
Okay. See, the hexagonal close pack is quite important because for the net gate, it is already quite important, but for the JAM aspirant also, because till this date, JAM didn't ask the question on hexagonal close pack. So there's a lot of possibility, a lot of probability that they can ask from the hexagonal close pack. Anything means C by A ratio, volume of unit cell, packing fraction, nearest neighbor, second nearest neighbor. Okay, anything they can ask. N effective, coordination number. So overall, all the 6 are quite important, but hexagonal close pack become more important because the question didn't arise yet from the hexagonal close pack. Okay.
सर ये NaCl के लिए जो लास्ट लिखा है वो √3 पूरा अंडर रूट में या
complete root of 3 by 2a. Complete root of 3 by 2a. Okay. आगे बढ़े. Okay. Should I rub it? हो गया सबका?
Yes sir.
Okay.
Yes, sir.
Now, our next topic will be lattice plate and Miller indices. But before going on that, I want discuss, it's a very little topic, but question frequently arises from there. And that is a density of crystal. Okay. If you follow the last year pattern, there is a very famous question on density of crystal. So first of all, we will see that, then we'll move to the lattice plane and Miller indices. So write down the heading, density of unit cell. Density of unit cell. Actually हम crystal की बात करते हैं ना, तो हम एक unit cell की density पहले find out करें. First we find out density of a unit cell. Okay. It's a quite means mathematical. Okay, इसमें physics जैसा कुछ नहीं है. It is quite mathematical. So if we talk about the density of unit cell, so this will equal to what? Density is equal to mass upon volume. That is mass of unit cell. Mass of unit cell and whole divided by the volume of unit cell. Volume of unit cell. Okay. In general, in your syllabus, we talk about the cubic lattice. Okay. In general, we talk about the cubic lattice. So for that, just we take the volume of the unit cell as A cube. Okay. A cube. But if different lattices came around, if in your question there's hexagonal close pack, then you can put the directly volume of the unit cell, that is 3 root 3 by 2 a square c. Okay, but we will talk about the cubic lattice. So mass of the unit cell and volume of the unit cell. See, volume of the unit cell, volume will be a cube. A cube. What will the mass of unit cell? Mass क्या होगा unit cell का? Mass of unit cell. Huh? Mass of unit cell.
An effective mass of one atom.
Yes, exactly. An effective multiplied by mass of one atom. Is it clear for everyone? See, it's quite trivial. Mass of unit cell. एक unit cell का mass आप कैसे define करोगे? First of all, we have to see what is the total effective number of atom in a unit cell. And each atom contain how much mass? Okay, just add all that. So N effective multiplied by mass of one atom. Okay, so N effective to ठीक है. Mass of one atom means what? If you talk about the means molar mass terms, so can we write this as N effective multiplied by capital M upon Na? Can we write this? N effective multiplied by the molar mass divided by the Avogadro number. Okay, so this will be small m. Now put both the value here in upper equation. What we will get? We will get, see, density of unit cell means rho. Rho is equals to small n. You can write down as n effective also, multiplied by capital M divided by Avogadro number multiplied by the A cube. This is the very famous relation from which question has been asked. Okay, that is n effective multiplied by the molar mass divided by the Avogadro number and A cube. That is the volume of unit cell. Clear hai? It's quite mathematics. There is nothing about the physics. ठीक है, physics ऐसा कुछ नहीं यहाँ पे. Simple एक relation है. This is simply a relation from where question has been asked frequently in different examination. So that's we discuss here. Okay. So this is your relation. We will see some numericals over this, and then we will move to the plane and Miller indices. I have sent you a question on your group before starting this class. Please see that.
Sir, sir, if we consider there are two type of atoms in a unit cell, then we cannot put m by na in place of mass of one atom. Then what can I do?
See, I'm telling you, na, I'm considering the cubic unit only. The unit cell is cubic here. Okay. And the different, see, the lattice, how the lattice will be changed. If you talk about the sodium chloride, then their respective everything will be changed. See, n effective will be similar. N effective will be similar. Na will be constant. Sodium chloride, we will take the molar mass of the complete NaCl and we will see about the volume, what they are saying. Okay. So this is, see, this is basic. This is fundamental. You can change anything with this. If अगर कोई अलग crystal आता है तो आप उसके according इसको change कर लो. Here we are talking about the cubic lattice only. Okay.
Okay, sir.
Okay. So just see the question. The first question asked in this year IIT-JAM exam. The lattice constant of copper we have to find in angstrom, which has FCC structure. Everyone able to see that question? Yes. Solve this. Everyone solve this on your notebook. I'm solving here. बताओ कितना आंसर आएगा इसका? Find out करो सब लोग. What is given? We have to find the lattice constant. That means we have to find the value of A. We have to find the small a here. And for the FCC structure is also given. That is FCC. FCC structure given. And other data also given. The density of copper is 8.91 gram per centimeter cube. Rho is given as 8.91 gram per centimeter cube. And atomic mass is 63.55 gram per mole. Okay. Atomic mass is given as 63.55 gram per mole. Okay. And the Avogadro number obviously 6.023 into 10 to the power 23 per mole or mole inverse. Okay, solve everyone. सब लोग solve करो. Data सब put करना है और कुछ नहीं है. N effective क्या लोगे? What will take the N effective for the FCC? That will be 4. Okay. N effective will be 4 for the, because FCC structure is given. Please solve everyone and tell me what the answer is coming. We have to find A in angstrom. Okay. You have to find the A, na? That is A cube. A cube will be equals to N effective, that is 4 multiplied by the 63.55. Okay. Gram per centimeter cube. And it will be divided by, sorry. Okay, molar mass is given. Na? 4 multiplied by the M. What is M here? 63.55. Okay, I was writing clearly. 63.55 gram per mole actually. It will be gram per mole. Aya kisi ka? Anyone has find out? Density and Avogadro number.
3.6.
Your voice is not clear. It's breaking.
361.9.
361 ऑर्डर बताओ एंगस्ट्रॉम में. वी हैव टू फाइंड द आंसर इन द एंगस्ट्रॉम. The question is given now, we have to find in terms of angstrom. 8.91 gram per centimeter cube. Okay, बस इसी फ्रैक्शन को सॉल्व करना है. A cube is given, huh? It is A cube. So basically finding out the A, we have to take the cube root. Tell me the answer. A is equals to, the answer
3.6.
3.6 angstrom. The answer will be 3.6 angstrom. Find करो सब लोग, जिसका नहीं हो रहा है ट्राई करना घर पे. Okay, let's move towards the another question. Second question I send you, that is atomic mass and density of sodium are 23 and 0.968 gram per centimeter cube respectively. Okay, we have to find the number density of valence electron. First of all, just tell me what they are asking. Number density means what? Number density means what?
Valence electron per unit.
N by V.
Yes, exactly. They are asking basically the effective number of atom per unit volume. Okay, that is, we have to find this. We have to find N, and N is stand for N effective divided by the A cube. Okay, यही हमें निकालना है. Find out करो. Please find out everyone. See what the answer is. The data is atomic mass and density of sodium is M is given as 23 and density is given as 0.968 gram per centimeter cube. Okay. Okay, that's it. And we have to find in the order of 10 to the power 22 per centimeter cube. Please find out everyone. Let's see what the answer is coming. Small n की वैल्यू बताओ. कितना है? What the answer is? I'm writing down the answer here.
2.533.
Yes, exactly. You are right. The answer is 2.53 or 2.54 into 10 to the power 22 per centimeter cube. This is the correct answer. Please see. आ रहा है सबका ये? Are everyone getting this? Okay. Okay. So I will send you some more question on this. It's a quite means formula base. You can try it by yourself also. Okay. So just these two questions from the last year and just for the practice purpose. So let's.
सर ये क्वेश्चन क्लियर नहीं हुआ.
ये क्वेश्चन क्लियर नहीं हुआ क्यों? क्या प्रॉब्लम आ रहा है? व्हाट्स द कंफ्यूजन?
सर ये हमें ये यहाँ पे जो हमें फॉर्मूला सब्स्टिट्यूट करना वो यही करना ना हमें. रो इज इक्वल्स टू एन इफेक्टिव इनटू जो आपने अभी ऊपर लिखवाया.
बिल्कुल वही यूज करना है. But what was the formula? See, the formula was density is equals to N effective multiplied by M divided by Avogadro number multiplied by the A cube. यही था ना formula. We have to use this, but in this question, what we have to find? We don't have to find N effective. We have to find the number density. Density stands for N effective by A cube. Okay, we have to find N effective by A cube. So that rho Na by M, that will be our relation. ठीक है?
Yes.
Okay. So let's move further. And the next topic we are going to start are the Miller indices and the lattice planes. Let's first talk about the lattice planes. Lattice planes की बात करते हैं. lattice planes. Anyone knows about it? What is a lattice plane? See, lattice planes basically connects the atom on any crystal. Okay, if you talk about, I'm giving you with example. Let's suppose I'm making a cube here. Okay, I'm making a cube here. Okay, let's suppose this is a simple cubic. Let's suppose this is a simple cubic for a while. Eight atom will be at the corner. Okay, so if you talk about the planes, and I told you planes connects the at least 3 point in a crystal. Okay, कम से कम 3 पॉइंट्स को कनेक्ट करना चाहिए एटलीस्ट, दो पॉइंट को कनेक्ट करने से प्लेन आपका नहीं बनेगा. Okay, let's suppose if you talk about these 4 points, these 4 atoms, one atom here, one atom is here, one atom is here, and one atom is here. If you connect these 4 points, okay, then this complete will form a plane. You will get this one as your plane. This is your plane. ठीक ना, प्लेन के बारे में आपको अंडरस्टैंडिंग होगी. आई एम जस्ट मींस telling you. Okay, similarly, if you talk about this one, let's suppose this is A, this is B, this is C, and this is D. E, F, G, and H. If you talk about E, okay, E, F, G, and H, also they are connecting the 4 atoms together. Okay, this will also make a plane. It will make a plane. Okay, this is another plane. So in a unit cell, ideally you can make infinite number of planes. You can make infinite number of planes. Okay, now so question arise, why we need to study means lattice plane, why we need to study Miller indices. Okay, so the thing is, see, all this stuff we are doing here are for the experimental purpose, right? The very basic and important phenomena or process you do when you go for the higher study is the X-ray diffraction, XRD, for any solid or any material. So when you do the XRD, we know what in the X-ray diffraction. X-ray diffraction means when an X-ray incident on any atom, ray get diffracted. So while seeing that diffraction, that okay, किस atom पे पड़ के ray diffract हुआ है, okay, उसका diffraction कैसा है, इन सबको स्टडी करने के लिए, for studying all this stuff, we need the Miller indices. Okay, bhai, it's a very general and theoretical concept na ki okay, I know that in any lattice there is some atom, there is a lattice point. On lattice point there is some basis, that is atom. But in an infinite lattice point, the means the solid has been extended in the infinite manner na. तो किस पॉइंट पे पढ़ के एक्सरे डिफ्रैक्ट हो रहा है, ठीक है ना? On which point X-ray are hitting and it get diffracted, how would I know? हमें कैसे पता चलेगा ये? So for understanding this concept, इसको समझने के लिए Miller, there was a scientist named Miller, there was a crystallographer in 1839. In 1839, he gave his concept. उन्होंने अपना एक concept दिया. Okay, and their concept, his concept was solely based on the integers. There was some, means you can say integer, which we denote as H, K, and L. Okay, you can say this as a notation also. उन्होंने कहा कि आप इसको as a notation use करो. He gave some means property, some unique definitions, and some process steps. There's a 2 or 3 steps we will discuss. He said, just follow this step and you will get to know the plane of the any lattice. Understood? So all this happening here is all about and due to because we have to analyze the data from the X-ray diffraction. Okay, so for understanding the concept of X-ray diffraction, we have to get something which we talk with mathematics. Theoretical बातें तो बहुत सी हो गई, अभी तक सब कुछ theoretical ही चला है ना. But XRD आप अगर कर रहे हो, so theoretical, how would you know that okay at which plane it has been heated and diffracted? So for that, Miller, again I'm telling Miller, there was a crystallographer in 1839. He gave his concept. He told that okay, there's some 2 or 3 steps. Just follow this step, and you will get to know. Okay, this is the lattice planes. Okay, understood? So this
Yes, sir.
was all about the lattice planes and Miller indices. Now, the concept arises how we will find out the Miller indices. It's very quite trivial. You guys, I know you guys have studied already in your graduation. How we will find the Miller indices? The basic question arises from here. So there was a concept, there were 2 or 3 processes I'm telling you. So write down the heading Miller indices. Miller indices. Today I will talk about only this step, and from tomorrow I will try to conduct your class on a digital platform, means on a digital board, so that for the Miller indices topic, so that the Miller indices planes you can get easily means analyze. Okay, usko analyze karna board pe. Sorry?
Evening only, na regular timing?
Yeah, evening. Don't worry. It's your class only. It will be your class. Okay? मज नहीं होगा, don't worry. मैं इसलिए ऐसा कर रहा हूँ क्योंकि मिलर इंडिसेस में प्लेन्स को समझाना ना इस बोर्ड पे बहुत ज्यादा, मतलब आपके लिए समझना ज्यादा दिक्कत होगा, समझाने की दिक्कत नहीं है. It will be quite difficult for you guys. So I will try to conduct your class, evening class, for the 2 or 3 class on a digital board, so that you can get easily means visualize. Okay, this is the plane. This is the plane we are talking about. Okay. So.
Sir.
Yes.
A doubt. Sir, अभी जो आपने cube बनाया था just for showing the planes, ना?
No. Just it is a cube, and I told you there is a infinite number of planes in a line in any lattice point. Okay, there is an infinite number. हम देखेंगे, हम सब कुछ देखेंगे. Don't worry. We will also see the parallel plane. मैंने infinite number क्यों बोला, हम ये भी देखेंगे. Okay ना? Don't worry. हम बहुत सारे examples की practice करने वाले हैं इसके लिए. Miller indices, आपका जितना भी doubt है वो सब clear हो जाएगा. Okay, don't worry.
No sir, मैं ये नहीं पूछ रही थी. आपने just जो cube बनाया था, वो just आपने जो parallel sides को show किए थे for the planes only, ना?
Yes,
Representing planes.
only for the planes. Just was giving you example.
Okay.
Yes. Miller indices. Okay. I told you already, this is basically a mathematical notation, and the notation stands with the HKL. Here, HKL is ज़्यादा significance नहीं है HKL का. It's just simply a notation. Okay. There is nothing question arise how HKL come around. It is just simply a notation. Okay. It is just simply a notation. ये simple एक notation है HKL. देखना. The main basic property, the main basic concept or step what Miller follows was taking the right hand coordinate system. What is the right hand coordinate system? Anyone knows what is the right hand coordinate system? The right hand coordinate system means nothing but
y z in a plane and x coming out of it.
Yes, exactly. हम XYZ ऐसे बनाते हैं ना, हम एक एक्सिस को, अगर XYZ एक्सिस को हमें रिप्रेजेंट करना है, हम ऐसे करते हैं. So the right hand coordinate system stand for right-handed coordinate system. See, the upper one will take Z, this one will take Y, and this will take X. ठीक है ना? We will only follow this coordinate system while discussing our Miller indices. समझना ध्यान से. ठीक है ना? हम इसी को फॉलो करेंगे. We will only follow this. X axis will be outward, Y and Z. Okay, why we are doing this? Very basic question. Why we can't take any other coordinates? See, Miller indices, the concept is solely based on notation. HKL integers पे depend कर रहा है ना. So एक fix करने के लिए कि that we are studying in India. Suppose we are studying in India. We are taking Y, X, Z. Someone is studying some in other country. There or left about the country. Just I am taking Y, X, Z. You are guys taking X, Y, Z. Some other was taking Y, Z, Y, X, Z. Then when you will change the coordinate, everything will be changed. बस समझ रहे हो ना भाई? आप कोऑर्डिनेट को अगर चेंज कर दोगे तो जो हमारे पास इंटीजर्स आने वाले हैं, द इंटीजर वी आर गेटिंग विल आल्सो चेंज्ड. सो फिर पता चलेगा कि 110 की अगर हम बात कर रहे हैं, इफ यू आर टॉकिंग अबाउट द 110, तो आपके लिए 110 कुछ और होगा, हमारे लिए 110 कुछ और होगा. आर यू गेटिंग माय पॉइंट? हमने क्यों राइट हैंड कोऑर्डिनेट सिस्टम यूज किया है? सो दिस इज अ बेसिक फंडा बिहाइंड द फिक्सिंग द कोऑर्डिनेट राइट हैंड कोऑर्डिनेट सिस्टम के ओके we all will follow this. That's it. Miller has said we all will follow this coordinate system. Okay. Now, there was a first process, first step was that we will follow the right hand coordinate system. What was the second one? What was the second step? Second step was finding intercepts. Finding intercepts on all three crystallographic axes. On all three crystallographic axes with respect to their lattice parameter. With respect to their lattice parameters. Okay, just write down the definition. We will see how it is following. I'm saying, okay, the first one was take right hand coordinate system. We took that. Second is saying finding the intercepts. Finding intercept on this axis, intercepts on this axis, and intercepts on this axis. What does mean intercept? Intercept का मतलब क्या? Intercept means at what distance planes are cutting this axis. At what distance planes are cutting this axis? At what distance planes are cutting this axis? Let's suppose I am saying this distance is A. I'm giving example. This is just example. I'm giving you example. This is A. Okay. This distance is also A. Let's suppose this distance is also A. I'm saying the y-axis intercept at a distance A. यहाँ पर कुछ कट हो रहा है. Z axis पे यहाँ पर कट हो रहा है और X axis पे भी यहाँ पर कट हो रहा है. Then these three together will make a plane. ये तीनों मिलके एक plane बना लेंगे. Okay? So we are talking about this intercept. हम इस intercepts की बात कर रहे हैं. We are talking about this intercept. So basically, for finding the Miller indices, we have to find the intercepts. कि किस point पे एक respective axis में उसको cut कर रहा है. Okay? So the second point was to finding the intercept.
Yes, sir.
Obviously, yes.
Sir, can you say what is intercepts cutting the axis?
I am saying what does it mean of intercept? Intercept means the cutting at some distance ना. भाई intercept का मतलब क्या होता है? जहां पर कोई चीज को cut कर रही हो. Okay? I am saying that let's suppose I have taken example. I am saying this distance, let's suppose this distance is A from this origin. This distance is A, this distance is A, and this distance is A. Okay? I have make a plane here, and this plane cutting this y-axis at what? At a distance A, cutting this x-axis at a distance A, and cutting this z-axis also at a distance A. While considering all these points, we have made a plane. हमने एक plane बना दिया है. ठीक है ना? सो these three called the intercept. Intercept means जहां पर उस एक्सिस पे उस प्लेन, वो प्लेन जो है जिस प्लेन की हम बात कर रहे हैं, that plane cutting the respective axes, that's called the intercept. Don't worry, we will see with the example, everything will be clear, don't worry. Okay, now right hand coordinate system we have taken, we have also find it the intercept. Intercept भी obviously it is quite obvious that हमें जो intercept मिलेगा वो किसके टर्म में मिलेगा? लैटिस पैरामीटर्स के टर्म्स में ही मिलेगा ना ऑब्वियसली. लेट्स सपोज वी आर टॉकिंग अबाउट दिस क्यूब. अगर हम इस क्यूब की बात कर रहे हैं, इफ यू आर टॉकिंग अबाउट दिस क्यूब, तो अगर मान लो यहाँ पर हमें कोई इंटरसेप्ट मिल रहा है, तो ऑब्वियसली दैट साइड इज व्हाट? साइड इज ए ना. सो द इंटरसेप्ट वी विल गेट विल इन टर्म्स ऑफ द लैटिस पैरामीटर्स, in terms of the lattice parameters. And
Sir,
yes.
Sir, here x, y, z are crystallographic axes. Okay, sir.
Yes.
But crystallographic axis may be non-orthogonal system.
See, I'm not going a north orthogonal or orthogonality. I'm just telling you the yes.
Because crystallographic axes are maybe orthogonal coordinate system or maybe
yes, exactly.
non-orthogonal.
Yes, exactly.
But you are taking only orthogonal coordinate system.
See, basically, it's not about the orthogonality or non-orthogonality. If we talk about any unit cell, I'm telling you, if we talk about any unit cell, there is only this right-hand coordinate system represent their respective axis. Whether it is ortho, yes.
Right-hand coordinate system is mandatory for determining Miller indices.
Yes, exactly. That's what I told. It is mandatory.
But crystallographic axes may be non-orthogonal. If crystallographic axes are non-orthogonal, then how can I find Miller indices for that case?
So what is the significance of orthogonality here? Orthogonality का significance क्या है? This, see, axis doesn't mean anything. Axis means we have to represent the planes. See, telling you, हमें एक plane को represent करना है. उस plane को represent करने के, obviously वो plane कहाँ पर है? वो plane unit cell में है ना? वो plane unit cell में है. उस plane को represent करने के लिए ये हमारा कुछ तरीका है जो हमने follow किया है. That's it, nothing more than that. All that concept is only for that unit cell. हमने ये जैसे मिलर का तरीका है. मिलर जो साइंटिस्ट है, the scientist was Miller, took this process. उन्होंने कहा कि follow these 3 steps and just find out the Miller indices. Nothing more than that.
Okay.
Okay. Okay. Okay. So what was the second step? We had found out the intercepts. Okay. Now the third step was finding out the Miller. देखो, राइट हैंड कोऑर्डिनेट सिस्टम ले लिया, इंटरसेप्ट भी फाइंड आउट कर दिया. अब बात आती है, द थिंग इज हाउ वी विल फाइंड द मिलर इंडिसेस. सो द मिलर इंडिसेस will be find it out. Miller indices will be find it out by what? Lattice parameters and divided by the intercepts. Simple. Lattice parameters and divided by their intercepts. Lattice parameter लो, उनको उसके intercept से divide कर दो. Obviously, when you will divide this lattice parameter by the intercept, because intercept also containing lattice parameter, then the variable will be cancelled out and you will get a number. Okay, you will get a number. That number, after changing into the minimum fraction, the fourth step was converting it into the minimum fraction. मतलब सबसे छोटा इंटीजर ले लो उसको. जैसे let's suppose there is a, you can say 644. Let's suppose we have find 644. So we can also write here na 322 by dividing the 2 here. Okay, so just converting into the minimum fraction. Okay, minimum integer you can say, convert into the minimum integer. So that is minimum integer will be the Miller indices. So we will follow from tomorrow this 3 step, and we will see there's a number of planes we'll take as an example, and we will show you that how these planes forming the means Miller indices, and basically how we can get the lattice plane by these numbers. Understood?
Yes.
And
So ये जो third
yes.
step है Miller indices का lattice parameter divided by intercept, इसका क्या meaning हुआ?
Don't worry. Tomorrow onwards, I will thoroughly tell you. Okay, this इसका कुछ मतलब नहीं है, simple देखो, lattice parameters obviously when you talk about the side, when you talk about any side, obviously that's if you talk about the cube, if you
Yes,
talk
sir.
about the cube will be, let's suppose the side of the cube is A, side of the cube is, so let's suppose A, and I'm saying on the y-axis the intercept as, let's suppose at A/3, A/3 पे intercept हमें मिल गया है.
Yes, sir.
Okay, so this is our what, intercept, and the
Yes, sir.
and the what lattice parameter is what, lattice parameter is what, A.
A.
So
A
that's
by
what I'm telling,
1
lattice
by
parameter
3.
divided by the intercept, that is A/3.
A/3.
That is A will be cancel out and you will get a number. That number will represent the Miller indices. ठीक है?
That number will represent the Miller indices.
That number will represent the Miller indices, but we have to convert into the minimum integer. Just I also give you example. Let's suppose it is in 644. Then we have to change in the 322.
Okay.
Just divided by the 2. All this is converted
Thank
into
you, sir.
integer. Okay. Okay. I mean, I will try to hold your class on the digital board so that you guys easily understand the planes. Yes.
सर रेसिप्रोकल नहीं लेंगे इसमें?
Sorry.
रेसिप्रोकल नहीं करते जो लैटिस पैरामीटर?
आप टेंशन मत लो, वो जो बुक वाली लैंग्वेज है ना, उससे कंफ्यूज मत हो, मैं जो बता रहा हूँ उसको करो, ज्यादा कुछ प्रोसेस करने की जरूरत नहीं, यू डोंट नीड टू गो एनी प्रोसेस रेसिप्रोकल और दिस और दैट, सिंपल लैटिस पैरामीटर डिवाइडेड बाय द इंटरसेप्ट, इतना करना, देखना सारे आएंगे. ओके, बुक्स की लैंग्वेज में ये करो वो करो, रेसिप्रोकल लो, नीचे वाला ऊपर को एलसीएम लो, कुछ नहीं करना है, डोंट वरी, आई विल टेल यू, जस्ट फॉलो दिस कॉन्सेप्ट, लैटिस पैरामीटर डिवाइडेड बाय द इंटरसेप्ट, हो जाएगा, सब हो जाएगा. आई नो आप जो बुक्स में लिखा रहता है ना, द टेक इनवर्स रेसिप्रोकल डिवाइडेड बाय एलसीएम, राइट, मेक अ स्मॉलेस्ट इंटीजर, वो सब कुछ भी करने की जरूरत नहीं है, फॉलो दिस मेथड, एक्चुअली दिस इज दैट मैटर. ओके, बट मैं थोड़ा सा, मैंने भी वही पढ़ा था अपने टाइम पे, डोंट वरी, ठीक है ना, बट फॉलो दिस लैटिस पैरामीटर डिवाइडेड बाय द इंटरसेप्ट, यू विल गेट every Miller indices for the every plane. Okay.
Okay, sir.
Okay, so let's stop here. So from tomorrow we'll see so many example of the Miller indices. Okay.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.
So after the class, please share the recording.
Yes, I'm going to share. Don't worry.
Thank you, sir.